We are asked to prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of those two integers. So let's pick two consecutive integers. I will pick n and n plus 1. They are consecutive, one after the other. Let's do the easy part first. Let's work out what the sum is. So the sum of those two integers will be n plus 1, which is equal to 2n plus 1. Now let's work out the difference between the squares of those integers. So difference between squares. So the difference between the two squares, so obviously I want to do the bigger number, so the n plus 1 squared, take away the smaller number squared. Otherwise, if I did it the other way around, I'd end up with a negative number. So you want to do the big one squared, take away the small one squared. If I expand this out, I get n squared plus 2n plus 1. If you weren't sure where that came from, you can just write n plus 1 times n plus 1. The n times n gives n squared. Then the n times the 1 gives n. The 1 times the n gives n. The 1 times the 1 gives 1. And then that gives the 2n. So that's where that came from. Take away n squared. We can see here that n squared take away n squared. That will disappear. And I will just be left with 2n plus 1. And we can see this is equal to the sum.